So hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. So we're starting the chapter here, ray optics. Okay. So before starting optics, I would like to introduce you related some historical events and concepts of optics. First it is optics, then after it is ray optics. Okay. So what does it means optics? Optics means a study of light. So student, optics is mainly is called a study of light. A study of light. And what is light? Light is a electromagnetic wave. Okay, it's a electromagnetic wave, EM wave. So if we're talking about light, in light, when a source, the ultimate source of energy, sun emitting the light, then all total three radiations are emitted by the sun. Starting from the lower frequency, first is infrared radiation. Okay, first is IR radiation. Then after second is, these are also called infrared waves. Then visible waves, and at last third wave is what? UV waves. Okay, so three types of waves are radiated by the sun: IR waves, visible waves, and UV waves. Okay, so the visible waves radiated from the sun comes to the earth in the form of electromagnetic wave. Okay, yes, the visible waves that came to the earth in the form of electromagnetic wave, these are the waves, and the direction in which light is propagating is a straight path. Okay, like when you travel in this style, and this is your initial position and your final position, then what is your exact target? This is straight line. So the straight line is said to be path of a wave. Okay, this is a style of a wave, type of motion, a style of motion, but ultimately this is your way of propagation. So the path of propagation, the way of propagation is called a ray. Okay, ray is what actually it is direction of propagation. Direction of propagation. Okay, got it? So this is direction of propagation is called a ray, and the type of propagation is called a wave. In which type the particle is moving, this type of motion is called a wave. Okay, so that's why we have to study wave motion, because wave is a type of motion. Okay, when we calling wave, then it means we are ready to analyze its motion. Okay, so this is called wave, and the directional path of the wave is called a ray. Okay, so in this chapter we have to study about the ray, means direction of propagation of a wave only. Now, so there are two type of optics are there. Optics having two branch. First it is ray optics, and second it is wave optics. Okay, ray optics means only you study about the direction of propagation of light. Yes. Okay, study about direction of propagation of light, and various phenomenon obviously related to the direction of propagation, like reflection, all the phenomenon. And in wave optics, this is related to motion of wave, related to motion of wave. and other effects. Okay. Yes, other effects related to the motion. Yes. So let's start with the ray optics. One more thing to realize ray optics. One thing is very uh, important for realize ray optics. The obstacle size should be greater than the size of the wavelength of light. Okay. Yes. Remember, ray optics is only realized when the obstacle size obstacle size means the size of the particle upon which is light was incidented. Okay, that is should be greater than the size of light. Size of light. What do we mean by size of light? Size of light is given by wavelength. Okay. Yes, size of light is given by wavelength. So if light is an electromagnetic signal, the distance between two successive crusts is called wavelength, or distance between two successive troughs is called wavelength, right? So for to realize ray optics, obstacle size should be greater than size of light, and to realize the effect of wave optics, the obstacle size should be less than size of light. Yes, here the obstacle size should be less than the size of light, right? Okay. So ray and ray optics. Topic number one, ray and ray optics. A ray of light is the straight line path followed by the light in going from one point to another point. Yes, when a light ray coming from one point to another point, so the path from which the light coming from one point to another point is a straight line path. Okay, this is the path of a light. Okay, the ray, the wave is moving like this, but the path of the ultimate path of the light become a straight line. So this path of the light wave or light signal or light radiation is called a ray. Yes. So a ray of a light is the straight line path followed by the light in going from one point to the another. The ray optics therefore uses the geometry of straight lines to represent the macroscopic phenomenon. Yes, we only here dealing with the path of light. Okay, so to deal with the macroscopic phenomenon, not microscopic observation, here it is only macroscopic outer observation in broad scale phenomenon like rectilinear propagation. What we mean by rectilinear propagation, the word rectilinear means combination of so many type of linear motion or linear propagation. Such a combination of linear propagation is called rectilinear propagation. Got it? Rectilinear propagation. Okay, so this is rectilinear propagation. And some more phenomenon in ray optics therefore uses the geometry of straight lines to represent the macroscopic phenomenon like rectilinear propagation, reflection, and refraction. Okay, so we have to deal with this type of geometrical phenomenon in this chapter. We have to deal with rectilinear propagation of light. We have to deal with refraction, and we have to deal with refractions. These are called optical phenomenon. Okay. Now, reflection of light. Starting with the first topic is reflection of light. Okay. See the syllabus, ray optics and optical instrument. The first topic is reflection of light. And all type of mirrors are here. Spherical mirror, mirror formula. Okay. So first part, this one is reflection. Totally reflection. Okay. Yes. So reflection of light. Everyone knows the reflection is the phenomenon of change of the path of light without change in medium. Yes. Or bouncing back of the light in same medium is called reflection. Okay. Now, mirror and some are also defined when a light reverse back, bounce back into the same medium, this optical phenomenon is called reflection. Important thing is that there is no change in medium. Remember, this line is very important. Without any change in medium. In reflection, the medium will be same. Okay. And if the medium will be changed, then it is said to be refraction. Now, talking about mirror, who will carry out the process of reflection? That is mirror. So mirror is a smooth and when polished surface which reflect regularly most of the light falling on it, called a mirror. Remember, mirror does not reflect 100% of light. It can only reflect most of the light. Okay, that is called a mirror. Okay, because some part of the light is also absorbed here. Okay, we will see in the wave optics that some of the light is absorbed in the mirror also. Okay, now in figure M1 M2 is a plane mirror. Here it is a plane mirror. Okay, a ray of light falls on the mirror along AO. This is called incident ray. Yes, yes, the ray of light that is falling along the AO is called incident ray. And angle AON, this is the normal. Normal is the perpendicular on the surface at a point of incidence. Okay, this angle is called angle of incidence. AON equals to I is called AON equals to I is called incident ray. Yes, the ray AO is called incident ray. This angle AON is called angle of incidence. Whereas the ON is the normal to the mirror at the point O. Incident ray is reflected along OB after the reflection. So this is called reflected ray. And the angle NOB, this one angle is called angle of reflection R. Done? Yes, R is known as angle of reflection. Now, this is the mirror surface. This is the angle of incidence. Now, what this is called? This is an imaginary plane. This is called plane of reflection. And try to understand the reflection will be takes in the same plane. Yes. If light comes according this plane, then it reflects in the same plane. Yes. Okay. Same plane. Yes. So incident ray, reflected ray, and the normal to the surface lying on the same plane. Okay. There may be so many plane at the same line. This one line. Okay. I am trying to make a different plane here. Can you realize here? This is a different plane like a paper of a book, page of a book. Yes or no? Yes, so there is a reflection only in this one plane. Okay, so there may be so many planes, but the incident ray, reflected ray, and the normal lying on the same plane. So laws of reflection, angle of incidence is equal to the angle of reflection. Angle I equals to angle R. And incident ray, reflected ray, and normal to the mirror lying on the same plane. Got it? Beam of light. Beam of light means light whenever there are so many lights, okay, condensed together, then they will form a beam of light. Okay, clear or not clear? Beam of light means so many lights are parallel, so many parallel lights, okay, combined together and they will form a beam of light. Okay, okay, incident ray OA, reflected ray OB, and normal ON on the mirror all lying on the same plane. Yes. Okay, coming to the spherical mirror. What is a spherical mirror? Okay, a spherical mirror is a part of a sphere. Okay, yes, you take a glass ball and polish everywhere with silver oxide outside. Okay, polish it everywhere with silver oxide. This is a silver oxide. Now, if you cut this mirror, then what will happen? Certainly, this point is the center of the is ball. This means sphere, right? Now take this hollow part, your cut out part outside, then there you will have two parts. And this is the reflecting surface. Yes or no? This outward surface is the polished surface, and this one is the reflecting surface. Okay. So when the reflecting surface is suppressed inward. So a cave-like structure is there. So that type of mirror is called concave mirror, right? So this mirror is said to be concave mirror when their cave-like structure is formed. Okay, so there are two type of spherical mirror. A spherical mirror is a part of hollow sphere whose one side is reflecting and other side is opaque. Yes, so here one side is reflecting and other side is opaque. See, this one is the reflecting side and this one side is the polished side, that is opaque. Clear? Yes. There are two type of spherical mirror. First is concave mirror. Yes, look here, this is the concave mirror. If if whose reflecting surface is towards the center of a sphere. Yes. Yes, later on. Concave mirror is called convergent mirror or converging mirror. Right. Okay. Concave mirror whose reflecting surface is toward the center. Here, check, this is the reflecting surface, and this reflecting surface is facing towards the center. Okay. Means it is suppressed inward. It is called concave mirror. Okay. As it converges all the light, that's why it is also called convergent mirror. Clear? This mirror is called convergent mirror as shown in figure. This is the center of curvature. Now, one important thing here is center of curvature. What is mean by center of curvature? The mirror that you have taken is the part of some sphere, right? The mirror you have taken is the part of some sphere. The center of that sphere, that imaginary sphere, is called center of a sphere, and the radius of the point of mirror, any point of the mirror to that center is called radius of curvature. So this is what radius of curvature. This is also radius of curvature. Okay. But remember, radius of curvature is only taken as this one length. Why? Let me answer. This is called only radius of curvature. Why? Because in a mirror, the center point of the mirror, exactly central point of the mirror, lengthwise central point of the mirror is called pole. Okay. And the line joining center to the pole is called principal axis. Okay, and the distance between center to pole is called radius of curvature. Got it? The distance between center to pole is called radius of curvature. Got it? So this is a radius of curvature. Now, remaining all the length, like in a circle, all the length like this. What are these? These are called normal. These are called normal. Okay. As all these lines making an angle 90-degree on the periphery of the circle or sphere, so these are called normal. So, however, the radius is also r. Okay, but these are not supposed to be radius of curvature. Only this one length from C to P is supposed to be radius of curvature. Rest are normal. Okay. Yes. So concave mirror, clear. Now talking about convex mirror. Convex mirror means when reflecting surface is outward. Here in concave, reflecting surface is inward, but in convex mirror, reflecting surface is outward. Okay. Like again, this is a glass ball, but you have polished inside. Okay. If you polished inside, yes, what? Yes. So if you polish the inside, then your reflector surface will be bulge outward. If you have cut this one mirror, then you have a structure like this. this. This is the final mirror. Okay, the cut out part that you have taken out is this. Okay, the side is the polished surface, and the outer side is the reflector surface. Right. Certainly, this point becomes the pole, the center point of the magnet, and the imaginary line that is passing through the pole. And see here, previously the reflector surface is towards the center of curvature. In the case of concave, the reflecting surface is focusing toward the center of curvature. Yes or no? Center of the sphere. But now here the reflecting surface not focusing towards the center of a sphere. Rather, this polished surface is focusing towards center of curvature. Yes or no? Center of a sphere. So here it will be the center of a sphere, and the line joining the center of a sphere to the pole is called principal axis of the mirror. This is C point called center of curvature, and this line is called what? This is called principal axis. Got it? This is called principal axis. Now this is reflector surface, and whenever you incident some light beams on this surface, then this will diverge the light. Okay, now light are getting diverging like this. So this why this mirror is called diverging mirror. Clear? Diverging mirror. Okay, later on we will see on what basis the light get diverged. Okay, yeah, so this is called convex mirror. Okay, convex mirror whose reflecting surface is away from the center of the sphere. Yes, here the reflecting surface, this is the center of a sphere, but the reflecting surface is away from the center of a sphere. Yes, this is the polished surface. Polished surface is towards the center of a sphere, but reflecting surface is away from the center of a sphere, or you can say it is bulge outward. Bulge outward. Okay. Concave, there is suppressed inward. Reflector surface is suppressed inward. Here it is bulge outward. Is called convex spherical mirror. Clear? There is a word cave because cave is formed. Yeah, see here. This is a cave made by the reflector surface. Okay. Whose reflecting surface is away from the center of a sphere. Okay. Of which the mirror is a part, as shown in figure, is called convex mirror. Got it? Now, some terminology, some important terms related to the mirror. First, it is center of curvature. What is center of curvature? It is the center of the sphere from what your mirror was taken out. Okay, the center of that imaginary sphere is called center of curvature. Like you have a mirror. Okay, yes, this is a mirror. Doesn't matter it is polished outside or inside. Okay, definitely this mirror is taken from some sphere. Okay, so the center of this sphere will become what? Center of curvature. Okay, center of curvature. Actually, when there is a complete sphere, it is said to be sphere. But if you taking some part of the sphere, then this part is called curvature. Okay, so the curvature will have the same center as it is a part of the same sphere. So curvature will have the same center, right? Okay, so center of curvature, the center of the sphere of which the mirror forms a part is called the center of curvature. It is represented by C. Very important. Throughout the chapter, we will use the letter C. Second is radius of curvature. The radius of the sphere of which the mirror forms a part is called the radius of the curvature of the spherical mirror. It is represented by R. The radius of the sphere of which mirror forms a part. Yes, means radius of the same sphere is called radius of the curvature. Okay, clear? Yes, the radius of the sphere of which mirror forms a part is called the radius of the curvature of the spherical mirror. It is represented by R. Now vertex or pole. The middle point of the center of the spherical mirror, you have taken a spherical mirror, and exactly the geometrically midpoint of this mirror part, this curvature part, is called as pole. Okay, is called, it is also called vertex. Another name is vertex or pole of the mirror. It is represented by point P. Okay, next, aperture. The effective diameter, aperture, the mouth of the mirror, you can say. Yes, this is the effective length of the mirror, M1, M2. If this point is M1 and the another point is M2, so this point is called aperture. Clear? Yes. So what is aperture? The diameter M1, M2. Yes, M1, M2 of the spherical mirror is called aperture. It is also called linear aperture of the mirror. Clear? Actually, aperture controls the amount of light. Greater will be the aperture, greater will be the amount of light. Okay? Yes. And if the curvature is high, aperture will be less. See here, this is extreme curved mirror. Yes. So here the curvature is high. If the curvature is more, then aperture is less. Here it is a small aperture mirror. Yes or no? And when curvature is less, see a type of flatness is there. Curvature is less. Yes or no? It is more curved and aperture is less. It is less curved, and when curvature is less, then aperture is more. Check here. It is more, it having more aperture. Yes or no? Yes. So inversely proportional relationship between curvature and aperture. Got it? Yes. So next, aperture of the mirror, clear. The diameter M1, M2 of the spherical mirror is called aperture or linear aperture of the mirror. Done. Angular aperture. The angle M1C M2. What is angular aperture? This total length is called linear aperture. We have seen just this is called linear aperture. But if you're talking about the angle made by this aperture at the center, yes, this is M1, this is M2, and they having mating and some angle theta at the center. So this is called angular aperture. Yes. The angle M1C M2 subtended at center C by the diameter of the spherical mirror, yes, is called the angular aperture. Got it? Yes. Here at the center, the angle subtended is called angular aperture. Next, principal axis. The straight line joining the pole and the center of curvature. Yes, straight line joining the pole and center of curvature. Here this is the pole and this is center of curvature. A imaginary straight line that joining center of curvature to the pole is called principal axis. Okay. The distance between center of curvature to the principal axis is what? It is radius of curvature r. Next, the straight line joining the pole and the center of curvature of the spherical mirror extended both sides is called principal axis of the mirror. As it is imaginary line, so you can extend it both the side. Okay. Principal section is section of the spherical mirror cut by a plane passing through pole and center of curvature of the mirror is called principal section of the mirror. A section of the spherical mirror cut by a plane passing through pole and center of curvature is called principal section. You see, this is a mirror, and you have cut this mirror by a plane passing the pole and center of curvature. Means you have taken a blade and cut this mirror from the exactly midway of this one. So the two sections are made up of or called principal sections. Clear? So a section of the spherical mirror cut by a plane passing through the pole and center of curvature of the mirror is called principal section of the mirror. Next, principal focus. Now it is important. What is principal focus? Very important principal focus. We have this one as a part of mirror. Now, when light incident when parallel light incident, when a light comes parallel to the principal axis. After the reflection, after the reflection, they passing through a point on the principal axis or appear to be pass. Yes, either in real sense passing through. Got it? Through. When there is real image, in real sense, the light will meet in a single at a point, then real image will be formed. Then this point is called focus, real focus, right? But in the case of convex mirror, they are appear to be meet at some point. Yes, this is the principal axis. Now parallel lines are here, parallel lines to the principal axis. Okay, now the reflection happens. So what will happen? The light will diverge like this. Reflection will take place. Got it? Now they are appear to be come from this point. Are they looking? Say yes or no? Yes. They are appear to be coming from this point. So this is called focus. Okay. And this is virtual focus. Clear? Yes. See, in this concave mirror, the light rays coming parallel to the principal axis. Yes, this is the polished surface. This is the principal axis. The light rays falling on the mirror parallel to the principal axis. After reflection, they get converged at a single point. Yes or no? This point at on where the light gets converged is called point of focus. Clear? So, in the real sense, in real time, lights are meeting and make a real image. So, this focus is called real focus. Okay. But in the case of convex mirror, the polished surface is outward, so it cannot converge the rays of light. And what will happen? Like if the light rays comes parallel to the principal axis, when light rays are coming parallel to the principal axis, then after the reflection happens here, then ray will reflect like that. Okay, agree or not agree? Yes, so reflect these rays like this. Now make them extend inside the mirror. Yes. In real time, they cannot meet, but they are just appearing to be come from this point. Yes or not? So this point is called focus. Okay. So in the case of convex mirror, your focus will be real. Here, your focus point will be real. Okay. But in the case of convex mirror, your focus will be virtual. Got it? Yes. So principal focus. It is a point on the principal axis of the mirror at which rays incident on the mirror in a direction parallel to the principal axis actually meet or appear to diverge. Yes, two things are there. Okay. Rays which are coming parallel to the principal axis. Okay. After the reflection, either they are actually meet. First case, this is about the convex mirror, sorry, concave mirror. And second, if there is a convex mirror, then what will happen? The rays will be reflected out, they get diverged, and they seem to be coming from a point. Yes or no? Parallel to the principal axis actually meet or appear to diverge after reflection from the mirror or appear to diverge. Okay. Yes. So they are getting diverged and appear to be come from this point. So this is called focus. So both the mirror having focus, one having the real focus and another having the virtual focus. Clear or not? Yes. In case of a convex mirror, F is a virtual point. Yes, I'm talking about this one mirror. In case of convex mirror, F is a virtual point where from the rays after the reflection appear to diverge. Yes, in the case of convex mirror, the rays are appear to be diverges from this point. Okay, appear to diverge. But in case of a concave mirror, f is a real. Yes, remember, here it is a virtual in case of convex, and here it is a real in case of concave. Okay, where the rays after reflection form the mirror actually meet. From the mirror actually meet. Okay, in case of concave, the rays will actually meet, so they will have a real focus. Got it? Look here in the diagram. Yes. So this is a concave mirror. This is the inside one surface is the reflecting surface. This is the principal axis that is passing through the center of curvature and pole. Yes, this imaginary axis is called principal axis. Now, when the light are coming principal parallel to the principal axis, they converges at a point is called focus point. Now, this length from pole to the focus, very important, is called focal length, is denoted by F. Right, beta? This denoted by F. Now, remember, each and every distance should be taken from pole. So now tell me, to reach the point F, you have to move leftward or rightward. Tell me. From P to F, you have to move leftward or rightward? To F, yes. Yeah, exactly, leftward. But the incident rays are coming rightward. Yes or no? See the direction of incident ray. This is left to right. But here you have moved right to left. Clear? So when you tracing in opposite direction of the incident ray, your direction will be negative. Your the distance taken will be negative. So here in the case of concave mirror, focal length will be negative. Like if you have moved 2 centimeter, then you should have to take f is equals to minus 2 centimeter. Got it? Clear or not? So all the distance should be taken from pole, and in the direction of incident ray direction, all the distance is taken as positive. In the direction opposite to the ray, distance will be taken negative. Clear or not? So focal length of the concave mirror is always negative. Okay, so make it a point. F concave is equals to negative. Clear? Now radius of curvature. Tell me radius of curvature will be positive or negative. So where is radius of curvature? This point. From pole to center of curvature, this becomes radius of curvature. So it is positive or negative? Yes, tell me. Is it positive or negative? Radius of oh, yes, from the pole to the point C. Yes. Again, you have to move against the direction of incident ray. Incident ray is coming from left to right, and you have to move from right to left. So R will be negative. Okay. So if it is 4 centimeter distance, then you have to write R equals to minus 4. Clear or not? Okay. Now, coming to the convex mirror. Yes, look, the rays are coming here from right to left. Now the rays are coming, they get diverged in this direction. Yes, too many rays are here there. As it is diverging mirror, so the rays, incident rays will be diverged. Now, make these rays extended in the direction of, make these rays extended, okay, and they are appear to be come from a single point. Yes or no? This point is called focus. Yes. Here the focus is virtual. Clear or not? Here the focus is virtual because in real time the rays are not meeting. We just imagine that they are coming from that point. Got it? So here the focus point will be virtual. Now tell me what is the symbol, sign of focal length here? Is it positive or negative? Focal length for convex mirror, positive or negative? Exactly. Focal length of the convex mirror will be positive. Why? Because check here. This is point P and this is point F. This is the direction of incident ray from right to left. And from pole to focus, you have to travel in the direction of ray of light. So it is equal to positive. So yeah, remember, for convex lens, focal length will be negative. Convex mirror, sorry. And for sorry. For concave mirror, focal length will be negative, and for convex mirror, focal length will be positive. Okay. Same here. Radius of curvature is also positive. Understood? As radius of curvature is distance from pole to the center of curvature, you again you have to move in the same direction of ray of light. So R equals to positive. Clear? Yes. So very frequent you have to use focal length is positive or negative in numericals. Okay. The distance of the principal focus from the pole of the spherical mirror is called focal length of the mirror. Yes. So focus point is represented by capital F, but the focus distance, that is called focal length, is represented by small f. So P to F is called small f, right? P to F is called small f. Yes. Now sign convention. So sign convention, I just given you idea of sign convention that all distances should be measured from the pole P of the spherical mirror. This is first rule. The distances measured in the direction of the incidence of light are taken as positive, and in the direction against or opposite the direction of incidence of light are taken as negative. Clear? So in the direction of incidence ray, all the distance is considered as positive, and opposite to the direction of incidence ray considered as negative. Now, the distances or the height measured upward the axis. If you measuring the height of the object upward the principal axis will be taken as positive, and when height of any object or anything you measuring the distance downward the axis, that will be considered as negative. Clear? The height measured upward and perpendicular to the principal axis of the mirror are taken as positive, and height measured downward are taken as negative. Clear? So, object, yes, check here. In the direction of incident ray, sign will be positive. In the distance traveled opposite to the ray, negative. The height upward is positive, and downward height is negative. Clear? Yes. Now, very important relation between focal length and radius of curvature. So what? Yes. Hmm. Yes, distance towards the right is positive and towards the left will be negative. Okay. Now, relation between the focal length and radius of curvature. Yes. Students, so this is the center of curvature and the distance up to here is called radius of curvature, capital R. And here it is point, focus point is here, and distance up to here it is called small f. Okay. So there is a relation between point focal length and radius of curvature. Check here, it is a point of focus. This is center of curvature. A small f is the focal length and capital R is the radius of curvature. So relation is f equals to r by 2, means focal length is just exactly half of the radius of curvature. Okay. Yes. So the focal length of a concave mirror is equal to the half of the radius of curvature of the mirror. Okay, not only concave mirror, for convex mirror also, it is half of the center of curvature. Look here, in the convex mirror, this is a light ray. When light ray get incident on the mirror, now check in what way reflection will take place. Here the complete idea of reflection is given. Let me explain. See, this is your mirror, okay? And this is your principal axis. Now, this is center of curvature and light incidented at this point, particular point. So, this is the point on the mirror. Clear? Now, join this point to make a normal. Why normal? Because reflection is defined across normal. When there is a normal, then this is angle of incidence, and this angle of incidence is equals to angle of reflection, right? So you should have a normal. Now make a normal. So normal is always perpendicular, and every perpendicular in the circle passing through the center. Yes or no? So make here it is a normal. Yes, now it's a normal. Understood? This is normal to the circle. Imaginary normal. Now, if this is an angle I, now plot the same angle and with the same angle R, light will reflected. Clear or not clear? Yes. So this I equals to R. And the light coming parallel to the principal axis after the reflection passing through a point, that point is called focus. Clear or not? So check here. The light incidented on this point. First we have plot a normal, join this point, this become normal. Okay, this is angle of incidence I and this is equals to angle of incidence R. Both the angles should be equal. Now by alternate interior angle, if this is I, then this is also I. So check here, by pair of interior angles, alternate interior angles, I and I looking here. Clear? Hmm. So mathematical concept of geometry also incorporated here. Now check here in the case of convex mirror. What will happen? First, this is the principal axis. The center of curvature of the convex mirror is towards the right side. Okay, as the part of the mirror lying here. Now, incident ray. First, make a normal. First, it is incident ray. Now, on the point of incidence, make a normal. So, normal is always passing through center of curvature. Clear or not? Yes, this is center of curvature. Now, we have find a normal. Now, check the angle made by the normal of incidence ray. So, here I is the angle. So, if I is the angle of incidence angle, in the same medium, reflected ray will be reflected by making the same angle. Clear or not? So, this is I, this is equals to R. Now, extend this ray inside the mirror and you will have a point focus, that is virtual focus. Clear or not? The reflected ray appeared to come from that point is called focus. So again, this is small f, positive f, and r is also taken as positive as it is in the direction of incidence ray. So small f equals to r by 2. Clear? Focal length of a convex mirror is equal to half of its radius of curvature. Clear? Yes. Now, some important rule. Okay, derivations is also there in our syllabus. So later on, we will see the important derivation related to this. Focal length of a convex mirror is equal to half of the radius of curvature. Clear. Some important rules. Now, make these diagram very important. First, the rays coming parallel to the principal axis passing through a point of focus. This is first rule. Second rule, if the ray is coming parallel to the principal axis, it is passing through the focus. But when it is coming from the focus after reflection, it will getting parallel to the principal axis, just vice versa. Can you realize? When coming through the parallel, when coming parallel, after the reflection passing through the focus. Okay, you can place a mirror here. Okay, then what will the reflection will take place? The light will reflect it and passing again parallel to the principal axis. Clear or not? Yes, two rules. Then next, if the light incidented on the point focus, sorry, pole, okay, so it having the same angle as reflection will take place, I equals to r. So if this angle equals to I, this angle also I, because I equals to r, so same angle will form. So light will reflect it along the this path, making a same angle with the principal axis. Clear or not? Next, if a light passing through the center of curvature, then there will be reflection. The light will tracing its own path from where it came. Okay, it will retrace the same path. Why? Theoretical evidences is here. You know, I equals to R. Check here. This is a normal. If this angle is I, this angle is R. Okay, and I equals to R. Clear? But when I equals to 0, then the laws of reflection R is also become 0. I means I equals to 0 means this angle continuously decreasing, and the value of angle decreases, decreases and decreases, and sometime the light will fall just along the normal. So if the light will fall along the normal, then I becomes 0. And the light along the normal making an angle I equal to 0, R is also 0 by the law of reflection. So light will retrace the same path. Yes or no? Same here. Check here. This is our center of curvature, and any light ray that is going like this, it is said to be it is falling in the direction of normal, because every line that is directing from center of curvature to the mirror is in the direction of normal. Yes or no? Because this is along the normal. So in normal, I equals to 0, so R is also 0. So light will retrace its own path from where it came. Got it? Yes. So this is basically theory. Now our next derivation is mirror formula for concave mirror. Okay. Mirror formula. You have to prove mirror formula means 1 upon U plus 1 upon V equals to 1 upon F. Okay, students. In class 10th, you must have read this one table. In different position, you have placed your object and you got your image at different situation. Okay. So again, you have to make this table and be very confident with all the situations at infinity, between infinity and C, at C, C and F, F and between this, and make all the cases. Yes. How? First case, when object at infinity. Okay. These are the positions. This is principal axis. When the object is at infinity, then what happen? The light rays coming parallel to the principal axis passing through the focus. Okay. So they will converge and make a sharp image, point size image at point of focus. So check here. When object is at infinity, your position of the image is focus. Okay, at focus. Size of the image is point size. Nature of the image is real, and orientation is inverted. Remember, when there is a real image, then always it is inverted. Okay, real image is always inverted. Clear? Now, make the object more closer than infinity. Then there will be this point is C, and you have placed your object here. This position is between infinity and C. Between infinity and C. Okay. Now make a ray diagram. All the ray diagrams in your book, your reference book, not in NCRT, but it is there in a reference book. Okay. So if the first you see with the red color only, the rays coming parallel to the principal axis, that is passing through the focus. Clear or not? First ray it is. and second ray that is passing through the center of curvature retrace its same path and you will have an image like this. Check here, this is A and this is B, and this is the reflected ray meeting here. So this point is B dash as it is pinpoint, and this is A dash. Clear? Now check the things. Yes, your object is between infinity and center of curvature. Your position of image is between focus and center of curvature. Yes, check in the diagram. Your image is forming between focus and center of curvature. Am I right? Yes, your image is between focus and center of curvature. And the size is diminished. Yes, your object is quite larger than the object. Check here, your object is larger one, but your image is diminished. Clear? Nature is real and inverted. Got clear? So same like you have to do all the points, okay, and make each type of image formation in your copy, okay, for convex mirror and concave mirror, okay.